Not really, so you just...
Alright, and we're recording. Okay, so first of all, looking at the first one. What's U?
Human.
X squared minus 4.
Right, so for the first one,
I got one part right.
so for the first one you've got x squared minus 4. So that was easy. Then you're going to take its derivative with respect to x. Now really what you got going on is, you first find the derivative of u with respect to x, and that is, you go from x squared to 2x, and the derivative of negative 4 is just 0, so you don't have to do anything about it. Then you get du by itself as 2x dx. Okay? Then you ask yourself, okay, what's the function of u? Well, the function of u is just this part right here. And that is that the f of u is equal to u squared. The last part is to rewrite the given integral in terms of u. So here we have the original integral. Do you notice how this part here, 2x dx, is already there? We don't have to change any coefficients, it's already good to go. So, we go on, and we already know that u is being squared, so we just write it as u squared du. The next thing you do is you actually evaluate the indefinite integral by way of taking the antiderivative. So, power goes up by 1, then you divide by that new power. So power goes up by 1, you get u cubed. Right? Then you divide by that new power. And what's the thing we need to add? Arbitrary constant, which is the c. Now we conclude by restating the integral as a function of x. So that you go back to your step 1, and you realize that u is x squared minus 4. So you have x squared minus 4 quantity cubed. Now you could have either had it over 3, that looks kind of sloppy, plus the arbitrary constant c. Another way you could have rewritten it was as 1/3 of x squared minus 4 cubed plus arbitrary constant. Either one of these would have been acceptable. So that one, pretty straightforward, right?
Sure.
Okay. Second one was, so that was in terms of the Conte-Sauce scale of mathematics, that was a mild one, right? Because we didn't have to change any coefficients. Okay, now we're going to make it a little bit spicier. We're going to go for the medium. Okay, so now we identify u here. U is pretty obviously what's inside the parentheses. So you have 3x to the 5th minus 17. We take the derivative of u with respect to x. So that's du dx is equal to, take your exponent here, that's 5. That multiplies by the coefficient. So we have 15x, power goes down by 1 to the 4th. Then we take the derivative of the constant negative 17 with respect to x. The derivative of a constant, of course, is 0. So we don't need to worry about it. Okay. To get du by itself, we then write it as 15x to the 4th dx. Now, you will notice we have the dx. You will notice we have the x to the 4th. What do we not have? Coefficient 15. Now, you will address that, but you won't address it in step 3. You address that in step 4. Step 3, I only asked you to tell me what's happening to the u. Well, what's happening to the u? It's being set to what power? 4th. So for step 3, you have f of u is equal to u to the 4th. A lot of people lost points because they skipped steps when I specifically asked for stuff. If I ask you to show me something, I don't care how pedantic it is. If you don't show me, you will lose points. Okay. Now for the rewriting of the given integral. This is the part when we rewrite the given integral, and I even said do not forget to correct for the coefficient. So, the first thing we should have done is you would have shown me that, okay, I needed to have 15x to the 4th, 3x to the 5th minus 17 to the 4th dx, and I have the 1 over 15. This is the part where I corrected for the coefficient. And then I rewrite it in terms of u. Now that I have this 15x to the 4th dx, now I can write it as this part here becomes your du, this part here is your u, and that's being set to what power? The 4th. So I have u to the 4th du. I'm taking the integral of that. What's outside the integral? 1 over 15. That was our constant coefficient corrective, if you will. Okay. Now we find the definite integral. Well, now it's just power rule, right? Now it's just taking your simple antiderivative. Your power of the exponent goes up, so you have u to the 5th, and you are dividing by the new coefficient. So that's u to the 5th over 5, and you still have the 1/15th on the outside, and now you still have the what? People lost points because they forgot arbitrary coefficients. I'm not going to name names, I'm just going to glare at people. So now we have the plus c. You probably want to simplify this further. U to the 5th times 1 is just u to the 5th. U to the 15 times 5 is 75. So we have u to the 5th over 75 plus c. Last step, we rewrite u as its original form, which was 3x to the 5th minus 17, which we had found in the beginning. So you have 3x to the 5th minus 17, that's being set to the 5th power, and you either divide it by 75 plus c, or, just like we had in the first one, you do it as 1 over 75, 3x to the 5th minus 17 to the 5th, plus your arbitrary constant c. Either one of these would have been acceptable. So far, so good. On to the next one, or not yet? We good? Yes, no? Almost?
Good.
Okay. Alright. So now we went from mild to medium, and now a little bit hot. Now this is not habanero hot, this is more like the Taco Bell. Yeah, it's hot, but it's more flavorful than hot. Kind of like banana peppers, although my wife thinks banana peppers are hot.
What about ghost chili peppers?
Neither one of us have had the pleasure of ghost chili peppers.
Do it. If you can.
We will see. Not right now. We have calculus to deal with.
No.
Okay, so the first thing is, again, to identify u. In this case, it's not what is inside the parenthetic, but what is inside the square root. So we have u is equal to x cubed minus 7 du dx is 3x squared. The derivative of negative 7 is 0, so then du is 3x squared dx. So then f of u, well, the u is inside the square root. So the f of u is either the square root of u, or we think of this as u to the 1/2. I think u to the 1/2 would be more convenient. Rewrite the given integral in terms of u. Do we have to do any correction of the coefficient? No. So we just write that this is the integral of u to the 1/2 du. Okay? Now, scroll up a little bit more. Power goes up by 1. 1 plus a half is 1.5, or 3/2. So we have u to the 3/2 divided by 3/2 plus your arbitrary constant. To clean that up, when you're dividing by a fraction, you are actually multiplying by its reciprocal. So you have 2/3 of u to the 3/2 plus your arbitrary constant. final thing we would do is go back to our original value for u and say, okay, our conclusion is that it's actually 2/3 of x cubed minus 7 to the 3/2 plus the arbitrary constant. You could have left it as a radical of a cube, but that would be extraneous and not very, it's not pretty. I feel pretty and witty. No? Alright. Okay.
Wait.
Okay, Charles,
Go back
get that
one
next
second.
word.
Sure.
Okay.
Now, this was the one that I kind of made some mistakes on. I asked you something that you were not yet expected to be able to do, but that only covers you for steps 5 and 6. Steps 1, 2, 3, and 4 you should have been able to do, and I gave you the points for step 5 and 6 whether you knew it was impossible or not. Even though in the middle of the test, after a certain individual brought my error to my attention, some of you decided to keep working. I'm not going to name names, I'm just going to glare at people.
I was done.
Alright. Now, first, what is u? U is going to be the one inside the parentheses, so u is equal to x squared minus 7. Okay? Then, we take the derivative of u with respect to x. I am thinking about putting the Crank That Song to the video in post-production, but right now I'm just trying to get it on YouTube so that absentees and mentally absentees can actually get this. We'll make them pretty later.
This is no time for that.
So you have du dx, of course, is 2x, and of course the derivative of 7 is 0. So then you've got du is equal to 2x dx, which is your numerator. Now, your f of u is just what's happening to the parentheses. Well, the parentheses is the divisor now, right? So, f of u is actually u to the negative 1. So you still were able to rewrite the given integral in terms of u, even if you didn't know how to deal with taking the inverse of a rational function. Okay. So the next part, you have the integral. Now, did we have to correct for any coefficients? No, we didn't. So now we just write this as u to the negative 1 du. At this point, that is where you could have stopped, and I gave you the credit for these, even though you weren't expected to know how to do this. Now,
I tried.
dealing with anything, let's take the idea of the u substitution and what we've learned from natural logs to the next level. We know that the derivative that the derivative of natural log is 1 over x, right? So, the antiderivative of 1 over u would be the natural log of u, right? Okay, so that's your indefinite integral, except what, and you got credit for it, right?
No.
Did it say okay?
No.
Show me. Well, show me after the video.
I crossed it out, but
Alright. Plus arbitrary constant, right? And then, last step, we are taking the natural log, but instead of u, what are we taking? What's u? X squared minus x squared minus 7, and we still have what? Arbitrary constant. Alright. And, not to make you all feel bad, but the corrections and talking my way through it and showing every step only took 14 minutes.